Today, well, first of all, my name is Daniel Melchior. I work in the MTI Instruments division of Vitrec. Today, we're going to talk about some of the products that we offer for the industry. The first one, we use non-contact capacitance sensors. We offer a host of different um, capacitance amplifiers, probes, both digital and analog options. So if you know, with the semiconductors, you can use these for displacement, thickness measurements, material processing, and those types of things. And today we're gonna focus on our two turnkey solutions. First, our manual gauge is the Proforma 300i on the left here, and our Proforma 300 ISA, which is our semi-automated wafer measurement system. These are used to characterize and test wafers that are in process for thickness variation, and our semi-automated system can actually map your entire wafer for thickness, warp, global and local flatness, along with bow measurements, and those things, which are very useful when processing to do a check on your wafer to make sure that you're within all the tolerances needed for the next stage in microchip uh, processing and manufacturing. So uh, our 300i is a manual gauge. Let me get to the next slide here. Hold on one sec. Okay, so we do use capacitance technology. If you're familiar with capacitance technology, the standard technology requires you to have the sensor sense to a conductive grounded target to complete the circuit for the measurement. What we employ is we have an exclusive push-pull capacitance technology that we use for our systems, which do not require a grounded target, which is excellent for both semi-conducting and semi-insulating materials. So you don't need a grounded target or anything like that for that. So the measurement principles, with these tools, it uses opposing probes. Our push-pull probe is actually two sensors built into one probe body. As you can see on the left here, there's a signal that comes out of the push side of the probe, and it goes across the target to the pull sensor, which is it's run at the same frequency, but there's a 180-degree phase shift, which basically shoots the target down one side and then sucks it back up the other. We use one on the top of the machine, or on the top of the wafer, and one on the bottom. And you can see the math on the right is how we calculate both the thickness and the shape of the wafer as it moves um, between the two probes. So you can get thickness variation. There's a host of different measurements that you can do, but this is the technology used for that. Our Proforma 300i is a manual gauge. So basically it's a small, it's probably the size of a big laptop. So you can put it right on your table or desktop. It has auto leveling. There's a bubble level. You can adjust it so it is parallel and flat for your surface. It's got a non-abrasive Teflon coated measurement stage. So you just place your wafer on top of the stage, and you can see that the wafer here is in between the probes, and the measurement is shown on the LCD display. So it does have a big LCD display. It does have a USB port on the front, so you can store and log your data for your thickness variation, and there's also a bow measurement that you can do with the Proforma 300i. All of our technology, both the 300i and the 300 ISA, give you an accuracy of a quarter of a micron, and it gives you a 50 nanometer resolution. So this can be used for wafers with a 1700 micron or 1.7 millimeter measurement range. So the probes are adjustable. So if you do have a thicker wafer, you can adjust it, calibrate it accordingly, and get your measurements. So it does do thickness, 5-point TTV, which is total thickness variation, center bow measurement. As you can see, it does have a high resolution LCD display. There's also Ethernet and RS-232 computer interface. There's also a software data logger program. So if you have a stack of wafers that you're testing, you can store that through the computer program if you want to, or through the front USB port to save your data. There's also these little pin guides which help you center your wafer if you're making a bow measurement. That is what that is for. So, and it, along with semiconductor wafers, you could actually use this for any material as well. So if you have, sheet metal, for example, or some other kind of material, it will work the same as long as they are between the two wafers. So you don't need to use it just for semiconductor wafers, but it is that. So it's a great tool to have. It's a great thickness gauge monitoring. We have many customers have this just to do a quick check of thickness, down to the quarter micron level. So it is highly accurate. But yeah, it's a great inexpensive alternative to a fully automated system. We do sell a lot of these units throughout the year, so it is a great product for us. And then here's a zoomed in picture of both the front keypad of the device, the display, and a quick snapshot of the data logger program. It does use a voltage from the top probe and the bottom probe, as you can see. And then you can export your data to Excel through a CSV file, save it through there. So you have all of that available to you. So it's a great tool to have on your workbench. The 300 ISA is our semi-automated inspection system. It does accommodate wafers between 75 millimeters and 300 millimeters. It does automatically scan your entire wafer, and it will give you a 3D map of your wafer for thickness and shape. So that includes, as you can see, thickness variation, bow warp, flatness. There's sight and sorry. There's a couple other things in there that if you need more information, I'd be happy to share with anybody. But again, in standard range, it gives you accuracy to a quarter micron with a 50 nanometer resolution. With the system, we do have a strong software package. We do give a laptop with this. I'll go into the components in a second. And it does have Ethernet capability as well, so you can control this and monitor things remotely through the Ethernet. So it's got the network capability. And it does, as you can see with the features here, it does meet the SEMI and ASTM standards. You can see for thickness, it's the ASTM F533. Bow is 534, warp is 1390 if you're looking at home, and the flatness spec is to the F1530. So if you need more information on that, I'm happy to provide that. But those are the specs for this. Now you can see the size. It basically comes in 3 different components. The controller controls the measurement stage, and that's where the data is gathered and is sent to the laptop computer. The middle is the measurement stage there. You can see the size. It does fit, on a small table. You can move it around if you had to. But basically, it's like a big record player. So it's semi-automated in that you have to manually put the wafer onto the stage, but then you just press the button through the software. It spins the wafer around through the measurement stage, and gives you a precise map, XY data of your wafer. So you can actually see that coming through. So it's not a huge machine. Some of the other features Like again, it does use our push-pull capacitance technology. It does measure pretty much, I'm not going to say all, but uh, pretty much all semiconducting and semi-insulating wafers. So it does include silicon carbide, obviously, silicon, gallium, indium, and other ones that are not listed here as well. So these do the standard wafers between 3 inches and 12 inches. It gives you a full 1,000 micron measurement range without recalibration. You can actually measure thicker wafers than this with probe adjustments, but the measurement range, the variation is up to basically a millimeter in thickness variation there. So it does meet all the ASTM standards, and it does use our computer interface that we give with the software is a Windows user interface. You can save data through CSV. There's a couple different options for that. So it does have Ethernet connectivity, and it does meet the SEMI standards for both health and safety and ergonomic compliance. So some of the biggest microchip manufacturers, in the world use this tool. They'll take wafers off their line, do a check to make sure that the shape is what they need for the next step in the processing. So this is just a quick overview of some of the software features. This is a lot summary. I know this picture is hard to see. This was a single wafer measured 5 times. It just kind of shows the repeatability of the thickness measurements here. So this is part of the software program that you see. So if you want to see the data in raw numbers, there it is. This is the median surface. So you can see for the same wafer, the median surface is shown here. This is a 3D model, so you can actually look from the top, the bottom, and then there's a little guide here that shows you, if there's any abnormalities or deviations from the center point. You will see that here. This is the median surface. Moving forward, here's a thickness outlook. This particular wafer only has a thickness variation of less than a micron, so this one is particularly flat. But if there was, we have seen some that look like, one of those Pringles potato chips. So you'll see it come up with a dip in the middle, and there's some with rough wafers. You see bumps in some cases. This is a pretty flat standard wafer here. This is the ASTM semi-compliant scan pattern. It is preloaded with the software. So this is a 300 millimeter wafer. This is all the points that the sensors will pick up. On this 300 millimeter wafer, you're getting about 3,200 measurement points around the full wafer, and then the center scan as well. So that is the scan pattern feature, and this is customizable. So if you do want to set up your own scan pattern, you can do that. If there's only certain areas of interest, say you wanted to look at just the center point, you could look at that as well. So there's a lot of different things that you can do with the software to customize exactly what you're looking for here. Again, this is the raw data points part of the software. You can see that there's 3,200 points here, and then as far as the XY of the map, you can actually take a look and see where you're at with thickness at different locations of your wafer. So you have a good map of shape of the wafer there. And then again, here's just a picture of, that's not me, but there's the laptop in the measurement stage. So you basically just use the mouse and it will start the machine and take your data right there through there.